Hey, space explorers! Welcome back to Explore with me, your ultimate gateway to unraveling the secrets of the universe. Today we're tackling one of the biggest questions in science. How did the universe begin? Get ready, because we're diving into the Big Bang Theory. No, not the sitcom, but the actual scientific explanation for the birth of the cosmos. From the tiniest moment of creation to the vast universe we see today, we'll break it all down step by step. So let's blast off into the origins of everything. 1. What is the Big Bang Theory? Host. Let's start with the basics. The Big Bang Theory isn't about an explosion in space. It's about the expansion of space itself. Scientists believe that around 13.8 billion years ago, the universe began as an infinitely small, incredibly hot, and unimaginably dense point, what we call a singularity. In an instant, this singularity started expanding, creating space, time, matter, and energy. Imagine blowing up a balloon. The surface of the balloon gets bigger, just like the universe expanded. Except this isn't just about inflating, it's about space itself stretching and growing. 2. Timeline of the Big Bang. Host, now let's zoom in on the timeline of events, Planck era, 0 to 10 to the negative 43rd seconds. This is the first fraction of a second after the Big Bang. It's a mystery zone where our understanding of physics breaks down. During this time, all the fundamental forces of nature, gravity, electromagnetism, and nuclear forces, were unified into one superforce, inflation period. In a split second, the universe expanded faster than the speed of light. This is called cosmic inflation. To give you an idea, something the size of an atom expanded to the size of a grapefruit. Crazy, right? This rapid growth set the stage for the universe as we know it. Formation of matter. As the universe cooled, particles like quarks and electrons formed. Quarks combined to form protons and neutrons, and eventually these combined to form the first atomic nuclei. At this point, the universe was a hot, dense soup of particles. Cosmic microwave background, CMB. About 380,000 years later, the universe cooled enough for atoms to form, and light was finally able to travel freely. This ancient light, called the cosmic microwave background, is like a baby picture of the universe. Scientists still study it today for clues about the Big Bang. 3. Key evidence supporting the Big Bang Theory. Host. Okay, you might be wondering, how do we know all of this? Great question. Here are 3 major pieces of evidence. Cosmic microwave background, CMB. Discovered in 1965, the CMB is a faint glow of radiation left over from the Big Bang. It's like a snapshot of the universe when it was just 380,000 years old, and it perfectly matches what the Big Bang Theory predicts. Expanding universe. In the 1920s, Edwin Hubble discovered that galaxies are moving away from us, and the farther they are, the faster they're moving. This means the universe is expanding. If you rewind time, everything converges to a single point, a key idea of the Big Bang. Abundance of light elements. The Big Bang Theory predicts how much hydrogen, helium, and lithium should exist in the universe. When we measure these elements, they match the predictions almost exactly. That's a big win for the theory. Common misconceptions. Host, before we go any further, let's clear up a few misconceptions about the Big Bang. It wasn't an explosion in space. It was the expansion of space itself. The Big Bang doesn't explain what caused the singularity to exist or what came before it. Why? Because time itself began with the Big Bang, so asking what came before doesn't make sense in this context. The theory doesn't say the universe popped out of nothing. It just explains what happened after the expansion began. 5. The future of the universe. Host. So what's next for the universe? Scientists have 3 main ideas. The Big Freeze. If the universe keeps expanding forever, it will cool down and become a cold, dark place where stars burn out, and life as we know it becomes impossible. The Big Crunch. In this scenario, the universe's expansion slows down, reverses, and collapses back into a singularity. Essentially the Big Bang in reverse. The Big Rip. If dark energy, the mysterious force driving the universe's expansion, gets stronger, it could tear galaxies, stars, and even atoms apart. Talk about a dramatic ending. Conclusion and call to action. Host, so there you have it, the Big Bang Theory, from the birth of the universe to its possible futures. It's incredible to think how much we've learned about our cosmic origins, and there's still so much left to discover. What do you think? Is the universe destined to freeze, crunch, or rip apart? Let me know your thoughts in the comments below. And if you enjoyed today's cosmic journey, smash that like button, subscribe to your